let's see. All right, this is recording. Now, let me just try to do this and show you. And let's see if it all stays together. Oh, I can do it. Wait, is this going to work? Let's see. Let's see. No, it didn't work. Okay, but you guys can see this right here. We are doing something conceptually challenging here. We are learning to graph trig functions, okay? So this is a day where you really got to be focused on what we're doing here. And today we're doing the sine function, and on Tuesday we'll do cosine, okay? They're very related. You'll start to see how they're related pretty soon here. But look at this unit circle. Let's just look at it for a second and see if there's anything we can kind of conclude. Because you could see that it is a unit circle because this point right here is at 1, right? It's 1 up, 1, 0. We know this point over here is 1, 0, negative 1, and this one's negative 1, 0. Okay, so this is just rotating around. It's just rotating around our unit circle. Now, what would you say is happening? So if I was watching, let me see if I could slow this down a little bit. One sec. Slider. No, they got this all locked in. Okay, so watch this dot and tell me, as far as the y-axis is going, tell me, you won't be able to tell me. Follow me with this. Once it gets to the starting point right here. It's at 0 for y. It goes up. It's at 1 for y. It goes down. It's at 0 for y. It goes down. It's negative 1 for y. And it goes back up to 0 for y. You see how if you were just paying attention to what is happening with the y, right? It's basically just going down, right? It's going down. It's going up. It gets to the top. Then it starts doing what? Goes down. All the way down to negative 1. And then it goes back up. Do you see if we were just focusing on the y variable, you would see that it's just going up and it's going down. It's just going up, it's going down as it rotates around the unit circle, okay? So now I'm going to zoom out a little bit and I'm going to turn on the next thing, and I want us to probably at first just kind of take a look at it and, you know, adjust as we look at this. Now, watch. The sine function is just noting how it is going up and down. As look at these coordinates here on the x. Look, it goes from 0 to pi, then it goes to 2 pi. The x-axis for this, the x-axis when we're graphing trig functions, is how far it's rotating around. How far it's rotating around. So from 0 to 2 pi, that's one full rotation around. Okay. Now watch when I turn this on, it's going to connect to all of that. Let's see. So it's going to start over again. Watch when it gets to the 0. Okay. See how it starts to go up? It goes all the way up to 1. Then it goes down. At pi, it's halfway around the circle. Goes down, and then it goes all the way up to 2 pi. That's all the way around the circle. Let's just let it go over again. It's going to go two periods here. Let's see. Okay, so it goes up. When it's all the way around, it's at pi radians. It goes down, and it comes back up to 0 at 2 pi radians. Okay, so this is about, let me see if I can slow it down. No, this is too, I'm not going to mess with that. So this is a matter of, we're looking at the sine function. The sine function is only noting how far up and down it goes along the y-axis as it goes along a certain number of radian rotation. So for instance, if it rotates right here and I were to stop it, how do I stop this? Let me see if I can do it. Oh, okay, here we go. If I were to rotate it here, okay. Think about the unit circle, and right at the top, remember here's 0, we rotate halfway around, we get to pi, right? We keep rotating around, we get to 2 pi, right? So here's the thing, if I'm rotating, and I get up to this point, it's at pi over 2, as far as my radians opening up. This is pi over 2. And if we look at what's happening, at pi over 2, it's at positive 1. So let's see if that works when we do this. let's go ahead and play it. Well, actually, I like this. Let's do this. No. So as we rotate it, right here, we've rotated, right, pi over 2, and that's why along the x-axis here, this is pi over 2, halfway to pi. And our values that we're looking at are the y values because sine is connected to the y values. So as we rotate pi over 2, we are at positive 1 right here. Well, it's almost positive 1, right? Now, if I continue this and we rotate around to pi, right? At pi rotation, what is my y value? The y value is here at 0, right? Close to 0. I can't get it exactly there. All right. So that means that along the x-axis at pi, it's going to be down here at 0. Now watch what happens. As I keep rotating around, when I get down to here, this is 3 pi over 2. And look where we're at. We're at negative 1. So as far as the rotation goes, we've rotated all the way to 3 pi over 2. And what we can see is we're at negative 1 at that point. And then look what happens. I'm going to keep going around, and I rotate. I keep going. And once we end up back at pi over 2 here, right? Full rotation is 2 pi. And at 2 pi, that's why the graph shows it at 0. I mean, it's at 0 if I were to get this closer and make it exactly. Okay, but let's just turn that on and notice it again. We're tracking. It's almost like we're tracking the y value. We're tracking the y value as we go around it. So we're at 0. We rotate around. We keep rotating. At pi, it's at 0. We keep rotating, and then at 2 pi, it gets back up to 0 again. So this is like, it's conceptual because it's relating what sine is always relating to the y value. Sine is always the y value, and we're tracking the y value as we rotate around a circle, and we are labeling and graphing what the function is doing as we go from left to right, from 0 to pi radians to 2 pi radians. This is actually a pretty big conceptual jump, okay? So if that is a little bit tricky for you to see, this is probably the most conceptual thing in Math 3, how these two things connect, okay? So in the chat, I got to track this. In the chat, let me know as far as what we're talking about on a scale from 1 to 5. Do you see the connection that I'm pointing out on a scale from 1 to 5? Like, be super honest with me as usual. On a scale from 1 to 5, how are we doing with it? Okay. So we're kind of in the middle, and it might be making more sense to some people and not to others at this point. So let's look at a more tangible example. So this is like rotation. This is actually like a lot of spatial kind of like space kind of reasoning of these things. Okay. So what I'm going to do is I'm going to go ahead and just turn on what the sine function looks like. Okay. This is a sine function. It starts at 0. It goes all the way up to 1. It goes down to 0 at pi. It goes down to negative 1 at 3 pi over 2. And it goes up to 2 pi right here. It goes up to 0 at 2 pi. Now, all this is doing is looking at a unit circle, which I could probably even pull it up to cross-reference real quick. Let me do that. Where'd it go? Oh, this is taking too long. I'm just going to do this. All right. So we have our unit circle right here. We have our unit circle. Let's get it. Okay, so look with me right here. When we're at 0 degrees, 0 radians, the y value is at 0, right? As we rotate around the circle, the y value is going up because we're going up, okay? As we get to 2 pi, what's the y value? 1. And then we go back down, we're rotating. We get to pi, what's the y value? 0. We keep going around the circle. Way down here at 3 pi over 2, what's the y value? Negative 1. And we keep going All the way around is 2 pi, and at 2 pi, what's the y value? 0. So let's see if we can connect that idea here. We're at 0. We're rotating around the circle, the unit circle. So at 0 radians, I'm at 0, because if I'm at my starting point, there's no movement up or down for y. Then I'm rotating around. Up to pi over 2, and that is denoted by pi over 2. Look what the y value is. 1. Okay. At pi, let's see what the y value is. 0. At 3 pi over 2, what's the y value? -1. At 2 pi, the value is 0. And it starts at 0, of course. So this is tracking the rotation around the circle, and the sine function is always connected to the y variable. So as we're rotating around the circle, we're basically just tracking how far up and down our y values go. Okay. All right. So I'm going to keep building on this idea, but this is, let me see, and we're going to come back to this, because not all sine functions are going to look exactly like this. This sine function is the parent function. A parent function is like before you manipulate it, before you squeeze it or stretch it or move it up and down. The parent function is the most basic function. And look what we have here. This is just y is equal to sine of x. That's the most basic sine function we can have. Now we're going to learn today how to, look at stretching this. Well, we're going to look at different points. And this is where, let's go back to the notes and look at that. So just hold this in your mind, and let's go back and see if this will allow me to do this. Oh, that'd be awesome. You could do it. Yeah, it'll do it. Let me get this up here. All right. So now we're connecting the different components. Because if I look at this down here, this is what we were just looking at with our graphs. Y is equal to the sine of x. This is the parent function. And I'll just give you a couple other examples of parent functions. Another parent function is y is equal to x. That's our linear parent function. You might have y is equal to x squared. That's our quadratic parent function, right? And then you get into, all of the parent functions are basically just the two variables without any other numbers added. So what we're going to see is that those numbers that make these more complicated, right? So x squared is really a basic function, but we've seen these before. We've seen x squared plus 5. We've seen y is equal to x squared plus x plus 6, right? And these are just more complicated versions of the parent function. Something is happening to the parent function, and the numbers connected to the parent function tell us what is happening. Okay? It's kind of like clues, okay? So we're going to start with our y is equal to sine of x. That is our parent function. And just looking at the components, I'm actually going to look at this part first. Looking at these components, we have a few different parts to it. We have the midline. That's always the first thing we find. The midline here is right on the x-axis. There's no movement up or down, but I could take this whole function and do what with it? Move it up. I could take the whole function and move it down. And that would change where the midline is. You see how that's right in the middle of the function. So I can move the midline up, and that'll move the whole function up. I can move the midline down, moves the whole function down. Okay. Now, that's the midline. We always look for that first. Then I look to see if there's a horizontal shift. So you notice how here it starts at 0. I could take this whole function and move it all to the right? And that would be a horizontal shift. So I can move it to the right, pi over 2. I can move it to the right, pi, right? So this point would start at pi over 2 or at pi if I moved it over. I can make it move over this way, where I move and I go negative pi over 2, where it would start over here and it would have the same shape. It would just be moved over, okay? So the two parts that we're talking about, we have the midline, that's moving it up or down. We have the horizontal shift, and the parent function does not have a horizontal shift because it's the starting basic function. Horizontal shift is side to side. And then there's just two more parts to it, okay? So looking here, the amplitude is from the midline up to the maximum. This is the maximum, right? Think of this as a roller coaster, right? It goes up, the amplitude is the maximum. and then we go down, right? And you'll see too that the amplitude here is expressed because the amplitude in this parent function is 1. It goes up to +1 as we saw with the unit circle rotation. It also goes down to -1, so my amplitude is 1. Okay, so amplitude is 1, it's going to go up and then down. If my amplitude was -1, it would go down then up. Okay, so we're just manipulating, we're flipping it around, we're doing all these things to the parent function. We're always addressing the parent function. The parent function is what, the parent function is our starting point. Okay, the last thing is probably the hardest part, and that has to do with frequency. And I'm going to reference it up here and then talk about this a little more too. But the frequency is the number of cycles within 2 pi interval. So look right here, between 0 and 2 pi, how many cycles do we have? And when I mean cycles, I mean before it starts to repeat. See how I made the dotted lines? Because it just keeps going. It's exactly the same. It goes forever. So how many cycles do I have from 0 to 2 pi in this instance of our parent function? Somebody tell me in the chat. How many cycles, full cycles, do I have going from 0 to 2 pi? From 0 to 2 pi. And that is our frequency. What do you guys think? So you see how this is going up, then it goes down, then it comes back to the point. This is the starting and ending point right here. It starts at 0, goes up, goes down, it comes back up, and that is a full rotation. Look what would happen next. It would go up, it would go down, and it would come back up. Okay, so this right here, right? A period is how long it takes to get before, how long it takes before you repeat. Okay, how long it takes before you repeat. So this is one cycle. This is one cycle because we go up, we go down, we come back up. And then it's going to go up, it's going to go down, it's going to come back up. And it's going to go up, it's going to go down, it's going to come back up. Yeah? So when I'm looking at this, when I'm thinking of the frequency, it's a number of cycles within the 2 pi interval, right? We have one cycle. So the period length is always going to be 2 pi divided by the frequency. And this might be something you just got to remember. The period length is going to be 2 pi divided by the frequency. But let's see if that makes sense. Because what is the frequency? How many cycles did I have? I have one. So I have one cycle. So if I'm trying to figure out the period, how long my function is going to be, I just have to think about it as, well, I'm looking to see what's happening between 0 and 2 pi. The frequency, it happens, one cycle occurred. So the period, how long it takes to go from start to finish, is 2 pi divided by the frequency, 2 pi divided by 1. The period here is 2 pi. Okay, this is a lot, guys. We're going to do a bunch of examples. You'll start to see how all these ideas connect together. Okay, but tell me now, on a scale from 1 to 5, how are you feeling about looking at the parent function? Give me a score. Give me a score in the chat. Okay, feeling okay? Feeling okay? Good. All right, thanks, guys. All right, so now we're going to go back up here, and this is where we're going to switch between this and our Desmos screen, because this looks incredibly complicated, right? But let's look to see what are the parts of it. We have our midline, okay? And I'm trying to make these really dark because these are the only things that are going to change. I'm going to focus in on the midline. And then I'm going to look to see what is right next to x connected with some function here, and that is going to be my horizontal shift. And then I'm going to look for the frequency, and that number is always out in front of x, and that's our frequency. It's like to find the different parts. Once you find these different parts, 1, 2, 3, and 4, then you're going to have the information you need to find what the shape is of the graph. Okay, so that is the key. First is to identify the 4 different parts, then we're going to be able to graph it. The last component that we have to look at is amplitude, and that is going to tell me how tall a roller coaster goes, how tall the roller coaster is from the midline. Okay, So let's put all this together. Let's look back at this screen for a moment. Okay, let's see. Let's do that. Okay, so we have this screen here, and look what we have. Right now, the blue is just our parent function. Y is equal to the sine of x. You see, that's what we were looking at. It's the exact same thing, you see. And if I even made an interval where I wanted to see just a part of this, you know, I can make this between 0 and 2 pi. Let's see if it allows me to do it. I didn't do it. I did this. I don't want to do it. I get the syntax for this wrong sometimes. All right, but look what we have. 0, it starts at 0. We rotate around pi over 2, we're at positive 1. We rotate around, we're halfway around the circle, and we're back down to 0. So we're just rotating around the circle. I keep going, 3 pi over 2, I'm at negative 1. I get all the way back up, and I'm at 0, full rotation. Okay. Now watch what happens. Watch what happens to these when I change the amplitude. I'm going to change it, or actually, we're gonna add another graph now. The red line here is gonna switch and change around. I have to do one thing first though. Let's see. I'm gonna do, this is gonna be 1. Okay, and then I'm gonna do A. So right now, look what our amplitude is. Our amplitude is 0. So the midline, we see the midline, right? Our D value, our midline is at 0. So that makes sense. Look where the red line is. You see how it's right there on 0. Now watch. I'm going to make the amplitude a little bit bigger. Let's see. You see what's happening? What's happening? It's going up, right? It's going up. The amplitude, watch what happens when I get to 1. It perfectly matches my parent function. You see that? Now watch what happens. I'm going to keep going. The amplitude is increasing, and I get all the way up to 2, okay? Now, if you're like, how the heck am I going to figure that out? Okay, well, so far we've only dealt with 2 components. We have the midline, which is at 0, right? 0. We know the amplitude is 2, so from the midline, I would have to go up 2. From the midline, I'd have to go down 2, right? And that is how these shapes start to happen. Now I'm going to put it back at 1, so it's going to match. Okay, and now watch what I'm going to manipulate. Get over there. Get over there. No, get over there. Yeah. All right, watch. Now look on your notes. And what was B? What was B again? B was what? B was our frequency, right? Now look at B right now. B is 1, and what that's saying is it has, right? It has 1 repeat or 1 full cycle before we get to 2 pi. You see how it starts here, it goes up, it goes down, it gets back to the circle. And we'd see that it repeats again, right? 2 pi, it goes up, it goes down, it gets back up at 4 pi. Okay. Now watch this. If my frequency is more than 1, watch what's going to happen. Look what happens. What if it's 2? All right, I'm going to get rid of this for a second. So if I make my frequency 2, look what happens. We go up, we go down, we get 1 full cycle by the time we get to pi. We go up, we go down, we get 2 full cycles before we get to 3 pi. You see, so frequency is just talking about how many full cycles. There's 1 full cycle, there's 2 full cycles, right? Now what's going to happen when I change this to 3? Let's see. We start here, always at the origin. We go up, we go down, 1 full cycle. We go up, we go down, 2 full cycles, up, down, 3 full cycles by the time we get to 2 pi. You see? So the frequency is just telling us how many full cycles we get. This is 4 full cycles. 4 full cycles is up, down, 2, 3, 4 full cycles by the time I get to 2 pi. You see? So frequency is just how many times we have a full cycle between 0 and 2 pi. It's always between 0 and 2 pi. So let's add this together now. Look on your notes. You see how it says frequency, the number of cycles within the 2 pi interval. And then the period is the horizontal distance before it repeats, right? We find the period by 2 pi divided by the frequency. What is 2 pi divided by 4, because we already figured out we have 4. The value for the frequency is 4. So what is 2 pi divided by 4? 2 pi divided by 4. Pi over 2. So if you have 4 cycles and the frequency is 4, that's how many cycles it takes to get to 2 pi. What that means is you take 2 pi, you divide by 4, and that's going to show you, whoop, that didn't work. That's going to show you how long it takes to get through one period right here. And it takes 2 pi. All right, let's go ahead and get this back. Let's go and get this back. All right, the last thing that I'll show, and this is less important, but our C value in here, our C value is a horizontal shift, and I just want to show you. Watch what happens. Look what happens. Horizontal shift. It's just moving left to right, right? So if my horizontal shift, if I found that my horizontal shift was positive 2 pi, that would mean that the starting point is here at positive 2 pi. Excuse me, positive pi over 2. If my horizontal shift was positive pi over 2, then it would be moved over and it would start at pi over 2. Okay. So all of this is still abstract. Thank you guys for sticking with me with this. I think we need to look at how this plays out. And we're going to do that by looking at a couple examples. Okay. Hey, why'd you do that? Get over there. Get over there. Get over there. Get over there. Yes. All right, everybody. This is what our homework is going to be. It's going to come from this. It asks you to find each part. And you know what? Actually, we're gonna just do A, B, C, and D. We're not going to use these indicators, but we are going to look at numbers 1 and 2 to start. And let's actually start at well, let me see if there's a better one to start with. Oh, I assigned you number 4. That's the best one to start with. Dang it. All right, how about this? I'm going to make some up. I don't want to do those. I'm going to go ahead and I'm going to write the function here, and we'll graph it. We'll graph it after we get it in there. Okay, so we're going to graph this right here. We're going to give it a try. We're going to graph y is equal to 2 sine of x. I'm going to turn it off so you can't see it. Y is equal to 2 sine of x plus 1. Okay. So everybody write that example down. We're going to be working on that example to start. And we'll double check ourselves, because once I click this, it's going to graph it for us. And I don't actually mind if you use Desmos as you're learning this to double check yourself. Okay, it's free graphing calculator. You can just put a function in, and you know, this was our parent function, right? So let's leave the parent function up there just to remind us. But now I'm going to go ahead and share back over here. Whoa, what just happened? That's weird. All right, new share. Let's see if this can handle it. So what you're going to have, if you watch this video, it's going to show you the Desmos and this screen right next to each other. So it's actually maybe even a little bit easier if you missed today and we're watching the video. So if that's you, you're lucky. All right, look, we're going to graph this. Y is equal to 2 sine of x plus 1. And when I'm doing this, it's very helpful, guys. Very helpful to have your basics down like this, okay? Because it's literally the position of the numbers tells you what it is, what aspect we're looking at, frequency, amplitude, and so on, okay? So let's first look at this, and let's go through and just identify our different parts, okay? So I look here, and the number that is out by itself is always the midline. So this is my midline. Okay, so literally you're just going into this, and you're circling and saying what each part is. Okay. Now I look here, the only other part, I look inside. Let's see, look at this part right here. This portion is sine of the frequency times x minus c. But I look in here because this is plus 1, that's that part, right? This is that part. So I'm just looking here, and I see that really the only modification I have here is that I have a b value, right? I don't have x plus 4. I don't have any kind of anything in there with x at all. So I don't have a c value at all. I don't have a c value at all. C, well, let's look at what we do have first. The only other part of this that we have is this number out in front of sine. That's always out in front is our amplitude. And that is the only other, it's the only other transformation up, down, left, right. You know, it's the only other thing that's happening compared to, you know, our parent function. You see, this is our parent function. The only thing that's different between our parent function and this is that we have a +1 out here, right? And we have a 2 out in front of the sine. That's the only difference. So those are the two things that changed in our parent function. Okay, so let's see what we have here. Let's go to our steps. Identify the midline. That's how far up or down it's going to move, and we did that. Okay, we know our midline is D. Look for the horizontal shift. Okay, I'm going to just write this so I know that our horizontal shift, 0. How do I know it's 0? Because C is our horizontal shift, and x minus 0 is x. Whoops. C is our horizontal shift, x minus 0 just has x. And that's what we're dealing with. There's no C value in there. There's nothing hidden, right? It's not x plus 4. It's not x minus 3. It's x plus x minus 0 because there's nothing connected. All right, so we got the horizontal shift. The frequency is our B value. Our B value, this is our frequency. And what is our frequency? Let's see. It's the value that is in front of x, or the expression containing x. So it goes sine, and then the frequency, and then x with an expression if possible. I keep doing that, sorry. The frequency is found after sine frequency of x. Okay, so I look here, look, sine frequency is right here. It's 1. There's 1x. If that was 2x, if we had this, y is equal to the sine of 2x, right? Then my frequency would be 2. If this was sine of 3x, my frequency would be 3. Sine of, what number can I make it? Sine of 8x, my frequency would be 8. Okay? So it's just whatever number is in front of x. Okay. Now we know that. We know our frequency is 1. Okay. So there's another part to it. What we just figured out is that between 0 and 2 pi, there's one cycle, one frequency cycle. So we have to now find the period. The frequency is the hardest part because then we have to find the period. Once we get all this together, it's going to be easy to graph, believe it or not. So the period is always 2 pi over the frequency. The frequency is always used to find the period. If the frequency is 1, then 2 pi over 1 is 2 pi. All right, so I got my period. I have my midline, my amplitude, my horizontal shift, my frequency. But here's the thing. Once you find the period, the frequency isn't that important of information. It's used to find the period. Okay. The amplitude we already found. The amplitude is 2. The midline is +1. Okay. And these are all the parts that we need to graph this. We have to know the period. For this problem, we have to know the midline is +1. We have to know the amplitude is 2. So you're like, oh man, so how is this all going to come together? I got a headache already. All right, don't worry. Let's go ahead and make a graph. And this is how you're going to set up your graph every time. Okay. You're always going to put in 0. And what I like to do is I like to go like 4 spaces and make this pi. And then go another 4 spaces just so you have space and make this 2 pi. Okay. You're always graphing the radians. The radians are always graphed. The rotation is always graphed on the x-axis. All right, everybody get the graph set up, and then we're going to start to work on putting the midline in there. We're going to look at the period, which is going to help us know how many rotations we have. We're going to look at the amplitude and all that. Okay, let's look at the midline. The midline is at +1. So look what I need to do. I'm going to actually go ahead and label my I'm going to go ahead and label my y-axis. I'm going to skip 1, get to 1, skip 2, get up to 2, 1, 2, like so. Negative. Right? Now watch how this all comes together. Tell me in the chat if you need me to slow down, if you need more time for the graph. Anybody? Just put a Y. You don't have to write anything. Just give me a Y in the chat if you need more time. Okay, here we go. Here we go. Watch this. Midline. Always graph the midline first. Midline goes first. Midline goes first. And watch. The midline is +1. Look what I'm going to do. Dash, 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 dash. How did I know to put it there? Because that's 1. At 1, that's where my midline is. So it looks like this parent function has been pushed up. It's been horizontally transformed up slightly. Okay. Now, it's actually helpful, to put next our starting point, because the horizontal shift is going to say where it starts. Okay. Now, the horizontal shift, it's always going to start. It's going to start on this midline, but we don't know where. But we look over here, and what was our horizontal shift? 0. So I know that my point, it's going to start, instead of starting at the origin, it's been moved up. It hasn't been moved left or right because we have no horizontal shift, but this is my first point. It's at 1, 0. It's not at the origin because the midline was moved up 1. Okay. Okay. And this is where I wanna go ahead, and now we're gonna look at, okay, what have we done? We did the midline. We did the horizontal shift. We're halfway there. Now let's look at the amplitude. The amplitude is 2, right? Now watch this. From the midline, right? From the midline, it's up 2. From the midline, it's down 2. Watch what I'm going to do. I'm going to put some dashed lines where the, that's not it. I'm going to put some dashed lines where this is going to be, because this goes up to 3. And look, from 1 to go up to the midline, let me get a Zuli back in here. 1 second. From 1 to go up to the midline, I have to go up 2, because the amplitude is 2. And watch, I'm going to put a dash right there. Here's the midline. Let's go down 2 to find the bottom part. And I'm going to go down 2. It's going to be at -1. You see how the midline is right in between the amplitude up and the amplitude down? All right, we have 3 parts done. The only other part is having to do with the period. So what I know is I get a full cycle within 2 pi radians. So watch what I'm going to do with this. I'm going to go ahead and make this is going to be the ending point. It's going to go up, it's going to go down, it's going to end up right here. Okay. So what we did was we put the midline. We know the amplitude is 2, so we go up 2, that's the top maximum. From the midline, we go down 2, that's the bottom, the trough, the bottom, the minimum. I looked at the period, it's 2 pi. So from the starting point, it goes 2 pi, and then it starts to repeat. But I'm only looking at one little part here. Okay. So look what we have now. We have a starting point and an ending point. Okay. We also know that these sine curves are totally symmetric. So right in between them is also a point that's on the graph, right there. And now we're going to start to see the shape come together. I'm going to add a couple more parts here. I'm going to add pi over 2. I'm going to add 3 pi over 2. Actually, that's what you should set up your graph every time. I want you to do this. 0, pi over 2, pi, 3 pi over 2, and 2 pi. You're always going to set them up like that. We're going to spend a couple days on this. This is intense, right? It's intense. You could do it, though. You could do it. We've already done standard deviation. We could do this. All right, now, here's the thing. I know, since I have a positive 2 amplification, or amplitude here, I know it's going to go up to the top. It's then going to go down. It's going to go through the midline. It's going to go down -2, down to the negative amplitude at the bottom, the minimum, and then go back up. So what I need to do now is to realize that the crest up here, the crest is going to be right in between the points. So I'm going to go up here and just put a point up there. I know that the minimum is right in between the points, right in between the points. So I'm going to put a point right there. And if you can see it, go ahead and make the sine curve, if you could see it. Here it is. Up, down to the midline. Down, up to the midline. And that is the function y is equal to 2 sine of x plus 1. Beautiful. That might be the most complicated thing you've ever done in your life. Maybe, maybe not. All right, get that one worked out, and then we're going to try one more. We're going to try one more, and this one, we are running out of time, so we're going to go right up to the bell. And we are going to graph this one. So make sure you got that all set up. Let's go ahead and graph. So I'm going to actually, for those at home, I'm going to go ahead and show this graph here on Desmos. You see, that's the one we just did. It has a midline right through, +1, amplitude of 2, down 2 as well. All right, let's try to graph this one. This one will be good. Let's graph y is equal to, let's do the sine of 2x minus 1. Let's do that. That's slightly different, right? Slightly different. This one's the harder one. Okay, and then go ahead and make your graph. Remember that we're always going to do those pi, 2 pi, pi over 2, 3 pi over 2. And I'm going to do the same. I'm going to do the same scale. Make this -1, -2, +1, +2. All right, so everybody get the graph all set up. I'm going to fold this. You can access this stuff. You know what, guys? I kind of have to run it a little bit for this last example, just because we have 6 minutes. You're probably not going to be able to keep up, but the video will be posted right after class, so you can access the last part of this, okay? So we need to look at this and in the context of our sine function. So when I'm looking at this, let's go ahead and just label what each value are, what they are. And you know what? I always say to start with the midline because that's also what is easiest to see. I always like to find the easy stuff first. So D is our midline. And D value is -1. C value is our horizontal shift. And we have no horizontal shift. Because look, it's just 2x. It's just 2x. It's not 2x plus 4, right? Anytime there's a C value, there's going to be parentheses, and it's gonna look like 2, the sine of 2x minus 5, okay, plus 3. It's always going to be in a parenthesis with it. So I just put these parentheses here to show that there's nothing with x, so our horizontal shift is 0. All right. Let's go ahead and get the amplitude out of the way. Amplitude. The amplitude is always found right in front of sine. It's a 1 out here. This is 1 sine. This is a 1 sine, okay? They don't put 1. They don't put it because it's just the first option. But this is an amplitude of 1. Finally, we're looking at our frequency. And our frequency is 2. So to find the period, we take 2 pi and we divide it by the frequency. And we get a period of pi. So we know that it's going to go and have 2 full rotations because the frequency is 2. We're going to have 2 full rotations to 2 pi. So 1 full rotation, one period is going to be just to pi. Because the frequency is 2, it's 2 cycles. That tells me that 1 cycle only takes pi radians to go through. Believe it or not, we have everything we need. So just because we have 4 minutes, I'm going to keep going. Sorry about this. But we're going to do, and I'm going to circle as I go. All right, we're going to do the midline. Midline is at -1. Here is the midline. All right, done. All right, I'll use different colors. Let's do, well, I'll do this one because it's already done. Horizontal shift? Nope, there's no horizontal shift. So right away, if there's no horizontal shift, this tells me that my first point is going to start on the midline right there at 0. If there was a horizontal shift, that would tell me where the starting point is. It would either be shifted to the right or left. Amplitude is +1, so it's really plus or minus 1. So look, from -1, I need to go up and find my amplitude. Up from -1 gets me back to 0. So here's my maximum boundary. Hope that's dark enough. Now my amplitude is 1, so it also goes down from the midline, and here's my minimum. Okay. 3/4 of the way done. Okay, lastly, we'll look at this, the frequency. The frequency is 2, and that tells me that there's going to be 2 rotations, 2 full cycles before I get to 2 pi. 2 full cycles. But really, the most important part here is the period. The period is pi. So watch what I'm going to do. I'm going to go ahead and put a dashed line down where the period is located. All right. We're still going to show all the way to 2 pi. We always show all the way to 2 pi. But I know that the period, it's going to get 1 full rotation and get back up to here. Another full rotation and get all the way back up to here. Right? So look what we have. We know that after 1 full period, it's going to end up back at the starting point. It's going to go up, it's going to go down, it's going to come back up. And the next cycle is going to be up, it's going to go down, and it's going to come back up. You always start the cycle over at the same y value, the same height. Okay. All right. Now I know that I need to make 1 full cycle before I get to pi. 1 full cycle. So I know I'm going to put a point halfway. I'm going to put 1 at the top, 1 at the bottom. So again, I'm going to put a point halfway. I'm going to put 1 at the top, 1 at the bottom. And now watch. Up, down. You see it? Once you know the period, once you know this is 1 period, that's 1 period, then you're really just knowing that it's all symmetric and it's always going to be, it's going to go through the midline and midway, it's going to be at the crest, a 1/4 of the way, it's going to be at the trough 1/4 of the way. So here's the other half. Boom, boom, boom. and we just graphed this function here. Okay. And I am realizing I'm going to change the homework. I'm just going to give you a few of these to work on. We're going to look through every single one of them on Monday. And I'll also make a video going over them. Okay. So I know this is tricky, but I believe in you guys. We faced a bunch of things this year, and we can do this. We can do this. Give me a rating from 1 to 5. How do you feel about this? Feeling better? Cool. All right, right on, right on. All right, guys, I need some votes. This will help me. I'll know how much I need to go over it more. Actually, I feel like I nailed that. I mean, not nailed it, but like that went all right. This is hard. This is a very hard thing to teach. All right. All right, I'm gonna go and stop the video. They got that little last bit in there. Yeah, you do, Dave. Everything that you can learn about waves, about light, about waves in the ocean, about fluctuations in anything, really everything.